Welcome to Session 5, Fractions, Complex Fractions, and Exact Arithmetic. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to preserve exact fraction structure, to simplify complex fractions, and to use magnitude as a check. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Exact arithmetic protects structure and prevents early rounding. Use this visual structure. Group is greater than common denominator, is greater than reciprocal, is greater than reduce. Read every symbol and label before calculating. The first goal is to preserve exact fraction structure. Connect it to the second goal. Simplify complex fractions. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Treat the large fraction bar as parentheses. State the target and preserve its units or conditions. Step 2. Simplify numerator and denominator separately. Use a separate line so signs, factors, and labels remain visible. Step 3. Multiply by the reciprocal of the entire divisor. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Reduce and compare size. Verification is part of the solution because it tests the answer from another direction. Signal 1 is addition or subtraction. Respond by remembering. Find a common denominator. Name the response before calculating. Signal 2 is division by a fraction. In that case, invert the divisor. The form tells you which tool fits. Signal 3 is a fraction over fractions. Remember, use separate simplification or an LCD. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Simplify 5613 over 14. Restate what is requested before touching the choices. The first move is, treat the large fraction bar as parentheses. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. The numerator is 1 over 2. Dividing by January 4th gives 2. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Multiply by the reciprocal of the entire divisor. The explanation supports one option without relying on its position. The mathematical conclusion is 2. State it with any required units, interval notation, or restrictions. The answer is 2. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Solve again with the least common denominator method. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Simplify x over 3 over 2x over 9, x0. Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. A focused hint. Multiply x/3 by 9/2x, then cancel x. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is 32. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to preserve exact fraction structure. Combine that with a discipline to simplify complex fractions. Finish by remembering to use magnitude as a check. A result becomes dependable only when the method and verification are both clear. Reflection. Should the quotient be above or below 1, and why? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.